Yes, hello Mandeep. Welcome on YourPedia platform and let's start your RAC snap for your final JKPSC interview for the post of Assistant Engineer in Public Works Department. So Mandeep, can you tell me something about refrigeration? What is the difference between a refrigeration and air conditioning?
So refrigeration is a process by which we try to achieve a temperature below the ambient temperature. And air conditioning is a process through which we try to look for the parameters like temperature, humidity, velocity, and purity of air. These parameters are concerned with air conditioning, whereas in refrigeration we try to minimize the temperature of a particular area according to our comfort.
Mandeep, can you tell me the difference between fine. Can you tell me the difference between ventilation and infiltration? Ventilation में और infiltration में क्या difference होता है? Ventilation and infiltration.
Sorry, sir, I have no idea.
You have not heard about infiltration?
No, sir.
What about ventilation?
Yes, sir. Ventilation is something like ventilation is a process through which, like in our, if we talk about theaters or in hospitals also, so like 100% ventilated air is something we use over there because the atmosphere of that area needs that level of purity to be maintained. So for that, we have ventilating vents around that particular.
Okay, Mandeep, ventilation means we are bringing some fresh air into the system. Okay, to maintain the purity level, the oxygen level in a particular region. So when we are intentionally bringing some air into the system, so that air is going to bring what kind of load on the system? Yes, hello, Mandeep. So Mandeep, I asked you, like when we are bringing some air, ventilation means the air which we are intentionally bringing into the system to maintain the oxygen level, the air purity in a particular, desired location. So when
Yes,
we
sir.
are intentionally bringing some air into the system, so that air is going to bring what kind of load on the system?
Sir, like in our homes, we have refrigeration equipments in our home. So in that we have a minimum input from outside air. Along with that, there is a recirculating air. So we basically try to use both the components. And at the meeting point,
Fine. I am just asking you, the ventilated air is going to bring what kind of load? The latent load only, the sensible load only, or both latent and sensible load? And what is the difference between latent and sensible?
So both the loads, I think.
Both the loads. What is the difference between latent and sensible load?
So latent load is like something in which we measure it by the difference in the specific humidity, and in case of specific load, we measure it by the difference in the temperature. That is dry bulb temperature is something that is the parameter for that.
Can you tell me brief about the liquefaction of gases? How we carry out liquefaction of gases?
So liquefaction of gases, we basically go for this Joule-Thomson experiment. It forms the base for liquefaction of gases. In case we have a coefficient mu, Joule-Thomson's coefficient mu, which is the ratio of del T by del P at constant enthalpy. And using this, we try to throttle the gas, and according to different pressures, we try to plot it on a T by P plot, and the point of maxima gives us the inversion point, and from there joining that.
I'm not asking about cooling. Throttling we use just to cool a particular gas.
Sir, Linde-Hobson.
Yes, good.
Linde-Hobson is a device we use for liquefaction of gas, and it works using the principle of Joule-Thomson principle for liquefaction of gases.
So there will be throttling followed by which process? Throttling and which process will be further there?
I've read it like it is used for liquefaction purposes of gases.
Mandeep, what do you understand by thermodynamic wet bulb temperature?
So thermodynamic wet bulb temperature is a temperature which is achieved by the equilibrium of the gases, that is the air, along with the water that is present in the wet bulb. that we have took. So by the equilibrium of these two air and the water vapor that is present, we achieve a temperature that is called thermodynamic wet bulb temperature. Normally, this is a property of a, like we normally say that this is a property parameter, and whereas for gases like air, the wet bulb temperature and thermodynamic wet bulb temperature both are equal.
Wet bulb and thermodynamic wet bulb temperature both are same.
So in case of gases like air, we take it equal because in case of that, the Lewis factor that we consider is very same for both the cases. Lewis factor is the parameter which we compare for differentiating the thermodynamic wet bulb temperature from the WBT.
Can you represent a evaporative cooling process on cyclometric chart?
Sorry, sir?
Can you represent a evaporative cooling process? The evaporative cooling process which we use in our desert cooler. So can you represent that process, evaporative cooling process on cyclometric chart?
Yes, sir. Yes, sir. So, like you said, for desert cooling, so the process would be cooling and humidification. So,
okay, fine. But how the temperature decreases, how the temperature drops in evaporative cooling process? What is the working principle of evaporative cooling? How it works?
so cooling coils are used for this. Like we are going for humidification. So we will go for some water vapor or some water vapor particles, steam, and we will be keeping it above the DPT temperature. So these are two parameters that we use. Cooling coils are used. Along with that, we can go for air vessel. Sorry, sir. There is an apparatus using which we can achieve the evaporative cooling very easily. I'm not able to recall that equipment.
Okay. Mandeep, tell me the working principle of VRS system. How a vapor absorption system works. I'm not asking the working. Just tell me the working principle of VRS.
So it uses low grade energy, heat energy for the purpose of refrigeration purpose. In this case, compressor is being replaced by a system of absorber, a pump, and a generator. And we normally use two types of refrigerants in this case. These are like the first one is ammonia water, and second is lithium bromide and hydro H2O for this VARS. So it uses low grade energy and mechanical, instead of mechanical compression, we go for a replacement of this by using our absorber, pump, and our generator.
Mandeep, what kind of cooling system we use in aircraft and why?
So the cooling system we go for in aircraft is reversed Britten cycle. So the main reason for using is that the requirement wise that the weight per ton of the refrigeration that is required can be very easily met by the air that is present in abundance. And since the availability of refrigerant can be issues at higher altitudes, so we normally go for air as a refrigerant.
You know, in air refrigeration system, there are so many devices required, like the evaporator. Okay, so you know, the basic components are there, like the compressor, expander. Expander is also required. Whereas in VCRS, we are having throttling device, which is much lighter than an expander. So how we can say that aircraft cooling system is lighter? You know, generally we use air cooling system in aircrafts because air cooling system is having a lighter weight per ton of the refrigeration. How we can say that air cooling system is lighter as compared to VCRS?
So air cooling system is lighter because in case of that, the engine certainly does double work. It helps to act as a compressor. It acts as a combined unit in which it does the work of compression also. So it helps to reduce the work over there. Whereas other parameters like expander and evaporator and condensers will be there for that according to requirement, but the compressor work is something I believe is minimized in our aircraft system.
Mandeep, my last question to you. What is the difference between an automatic expansion valve and a thermostatic expansion valve?
Yes, sir. So automatic expansion valve works on a constant pressure principle, and it is used where in areas where there is a fluctuation, quite a bit less fluctuation. Fluctuation is quite a bit there. There we go for constant pressure one, and automatic one, and another one, that is the thermostatic one, is it helps us to maintain a constant degree of superheat, and it is used in places where there is a constant fluctuation, like very less fluctuation comparatively.
In cold storage plant, what kind of expansion device we use in our refrigerators and why?
So capillary tube is used.
Why capillary tube?
So because it is quite easily available and it can easily does the work that is required out of it.
Okay. Okay, Mandeep, my last question to you. What is relative humidity and how we measure relative humidity?
So relative humidity is denoted by the term phi, and it is the ratio of mass of vapor to the mass of saturated air at a given given a temperature and a given volume of air. And for like if we say that phi is 100, then the air is fully saturated air. So this is basically the amount of heat content, amount of vapor content a gas can at its very maximum value attain.
Chalo. Okay, Mandeep, I think now I can provide you the feedback. Okay, Mandeep, I think thoroughly you studied that subject. I asked you some random question. Okay, from air refrigeration, some cyclometry, some VCRS, ERS question I asked you. So confidently, comfortably, you tackled all those questions. You know, the capillary tube is a very cheap device. The cost of the capillary tube is very less, and also in our domestic refrigerator, the load variation is very negligible. Okay, if you compare with a kind of cold storage plant where the load variations will be much higher. So capillary tube, fixed amount of refrigerant is going to flow. Okay, so that's why we use capillary tube in our domestic refrigerator due to very less variation in the load and the device cost. Okay, which
Yes,
also
sir.
is much lesser as compared to other kind of expansion devices. तो मेरे ख्याल से some working principle of VRS is what you have actually correctly you have not answered that. You know, when some refrigerant is going to absorb by some absorbent, its vapor pressure is going to drop, Mandeep. So
Yes,
in
sir.
VCRS, the refrigerant movement from the evaporator to the compressor is carried out by sucking the charge. You know, compressor suck the charge from the evaporator so that, you know, further enables the system to move the refrigerant into the system. Okay. Whereas in VRS, the suction is carried out due to the pressure difference created between the evaporator and absorber, because when some refrigerant will be absorbed by some absorbent, its vapor pressure is going to drop. That is the nature. So when water
Yes.
will be, if you take water, pure water, and if you take 50% mixture of lithium bromide and water, okay, so its vapor pressure will be lesser, Mandeep. That's why
Yes, sir.
water will easily move from some evaporator section where it is available in the pure form to the absorber where it is available as a mixture. Fine, Mandeep. That is a
Yes.
working principle. How we are moving the charge inside the system.
Yes, sir. Yes, sir.
So, other than that, I asked you about liquefaction of gases. That you answered. You know, throttling and the compression. We need to carry out the compression as well as throttling. So Linde technique, what we do, we compress a charge, maybe the gas which we want to liquefy, then we carry out the throttling, again compression, then throttling, again compression, throttling, till we will get the what, a kind of liquefied gas. Are you getting
Liquefied gas. Yes, sir.
Further you can check, you can get more idea about that Linde technique, how we carry out the liquefaction of gases. There are some techniques by which we can produce very low temperature, like the cascade system, multi-stage or multi-evaporator system, okay, multi-stage compression system. With these kind of things, we can produce very low temperature. Okay. तो मेरे ख्याल से ठीक है, आपका अंडरस्टैंडिंग इज गुड मनदीप. करेक्टली यू आंसर्ड मोस्ट ऑफ द क्वेश्चन. Evaporative cooling example you can highlight of desert cooler, na Mandeep?
Yes, sir.
Desert cooler, but the earthen pots also, the earthen pots which you are having
Yes,
in
sir,
them
yes,
also,
sir.
we carry out some kind of evaporative cooling. तो क्या होता है?
Yes.
When water is going to evaporate, okay, it requires some it requires some heat, because liquid is converting into vapor. So from where it is going to take the heat, it will take heat from its neighboring particle, neighboring molecules. So that's
Yes,
why
sir.
in evaporative cooling, due to the vaporization of some part of the liquid, the temperature of the remaining liquid present in a particular container will drop, and that is how we are going to get the low temperature or maybe refrigeration.
Yes, sir.
So that is a what kind of example and the working principle of evaporative cooling, कैसे उसमें temperature drop होता है. Fine मनदीप.
Yes, sir.
चलो, तो ठीक है, मेरे ख्याल से आपका अंडरस्टैंडिंग ठीक है एंड करेक्टली कॉन्फिडेंटली यू आंसर्ड मोस्ट ऑफ द क्वेश्चन मनदीप. तो डिलीवरी स्टाइल में कोई इशू नहीं है, यू आर लुकिंग कॉन्फिडेंट एंड योर प्रिपरेशन इज आल्सो लुकिंग गुड मनदीप.
Yes, sir.
Good luck and best of luck for your final interview.
Thank you, sir.